Chapter 5, Lesson 1, Solving Inequalities by Addition and Subtraction. So solving inequalities is just like solving equations. There's a few differences, obviously, but we do the same types of steps, and our goal is also the same. Our goal, as you remember in equations, is to isolate the variable. And that's also our goal in our inequalities. And how do we do that? How do we get that variable all by itself? We use inverse operations, or those opposite operations, just like we do in equations. Okay, a few things that are different. The main thing that is different is that inequalities have many solutions. Equations only have one solution. Sometimes they have none or infinite, but in general, equations have one solution. And inequalities have many solutions, because now x doesn't just equal 4, x might be bigger than 4, which means that x could be 5, or 10, or 4.2, or 5.5. X might also be less than 4, which means x could be 2, or -8, or 3.9. And so it doesn't just have one solution, it has many solutions. When solving inequalities, you also must graph the solution. So that's another difference, is that when we get a solution, we have to graph it. So if we have x is greater than 4, we graph it and we say, here's 4 on my number line, and x is going to be anything that is on the right side of 4 that's bigger than 4. So let's talk about what those symbols look like, what the words mean, and what an example of a graph might look like. So our first symbol that we're going to look at is our symbol that looks like this. And when we read that, that is our greater than symbol. And an example might be x is greater than 9. And when I graph that on a number line, I say, well, here's 9. And so my x is anything that is to the right of 9. It can't be 9, that's why I don't fill in that circle, but it's anything to the right of 9. Our next symbol is our less than symbol, and an example would be x is less than -5. So on a number line, we say, well, here's -5, and my x is anything that is less than it, which is anything over here to the left of it. All right, another symbol that we're going to see is greater than or equal to. So this symbol says greater than or equal to. So if I have x is greater than or equal to -1, then I go to my number line and I say, well, here's -1. Now I fill in this circle because x can also be equal to -1, or it's anything that's bigger than -1. So it's anything that's over here to the right of -1 on my number line. And then in the opposite, I have less than or equal to. And those are my 4 inequality symbols. So an example would be x is less than or equal to 0. Here's my number line. Here's 0. X can actually be 0 because it can also be equal to it. That's why I fill in that circle. And it can also be anything that is less than it. The reason that we graph these solutions is because it helps us visualize all of the numbers that x could be. So like for example in this last one, when x is less than 0 or equal to 0, I can visualize that it's any of these numbers over here. It could be -1, it could be -10, it could be -100, anything that would continue on my number line that way. So when I solve inequalities, like we said earlier, we solve them just like equations. So if I look at this first one, x minus 12 is greater than or equal to 8. So I would say plus 12 because I want to isolate that variable. X is greater than or equal to 20. And then I'm going to graph my solution. Here's 20 on my number line. X can be 20, so I fill in that circle. But then it can also be anything that's bigger than 20. So I make a big arrow going to the right to show that. Okay, the next one, m plus 19 is greater than 56. So I do minus 19 to get that m by itself, and m is greater than 37. I'm going to make my number line, And I say, here's 37. M cannot be equal to it, so I leave that circle open, but it can be anything that's greater than 37, and so my arrow goes to the right. And my last example, 3a plus 6 is less than or equal to 4a. So I have a's over here and a's over here, so I need to get rid of them on one side. I'm going to choose that smaller one and do minus 3a minus 3a. Those cancel. 6 is less than or equal to a. 1a, but that's the same as a. Now this one might get a little bit tricky when we graph it, because we say, well, here's 6. Another way that I can write this inequality, I can switch the sides of the 6 and the a, but then I have to change my inequality symbol. If 6 is less than a, then a is greater than or equal to 6. So again, it can be 6, can be equal, so I fill in that circle, and then I make an arrow. It can be anything bigger, so I make an arrow to the right. Now, it's not required of you that you change this symbol and change it to read it like this, but it is easier to graph if your variable is on the left side. So you don't have to, but it will probably be helpful to graph it when your variable is on the left side.